Hi everyone, my name is Eileen. I'm a junior studying biomedical engineering here at the University of Iowa, and today I'm going to talk to you a little bit about the Roy J. Carver Department of Biomedical Engineering. So, biomedical engineering is relatively new, and the term is pretty broad. It covers a lot of different areas. So, what exactly is it that biomedical engineers do? We apply engineering principles and design concepts to medicine for improving human health, which includes things like diagnostics, monitoring, or therapy. We design and create medical equipment and devices, process and analyze medical images, develop new materials for tissue engineered implants. We use computers to analyze genetic structures and functions, and we even become doctors or physical therapists, occupational therapists, dentists, lawyers, and so many other things. There are biomedical engineers in every corner of the world. So here are some quick facts about our department here at Iowa. We have been ABET accredited since 1984. We were recently gifted $12 million by the Roy J. Carver Charitable Trust, which allows our department to continue to grow and thrive in places like getting more professors or different labs where we can explore different topics. Our current undergraduate enrollment is at about 500. We are currently 45% female, which is super awesome in comparison to the national average of 27%. There are 20% of women in engineering. After graduation, about a third of the students in the Department of Biomedical Engineering will go off into industry. About a third will go to professional school, which is like medical school or law school. And about a third will pursue research or something like a master's or PhD. We are currently located in the fifth floor of the new annex. The new annex is super nice. All of our professors have an office up there, so if you have any questions in between classes or for office hours, they're super convenient to reach and they're always really happy to see us. There are also some really cool study spaces up there if you need to complete any homework or study anything after classes or between classes, which is super nice. So within biomedical engineering, there are four focus areas, or what we call tracks. There's biomaterials and biomechanics, bioinformatics, bioimaging, and cellular engineering. So I'm just going to talk a little bit about each one. So biomaterials and biomechanics is the study of injury, degeneration, repair, and regeneration of tissues. Biomaterials is the ability to develop biocompatible and biodegradable materials. So if you have something implanted into your body, you don't necessarily want it to fail or corrode and cause further damage internally. So it is necessary to have a selection of materials for device application and how to problem solve in case of material failure. So if for whatever reason the device fails inside of your body, you want to make sure that you're able to get that out with minimal to no harm. Biomechanics is the study of solid mechanics, which focuses on tissues and structures, and fluid mechanics, which focuses on blood and blood vessels. They also design and manufacture orthopedic implants, prosthetics, and orthotics, and that covers a wide range of things like cardiovascular devices or wheelchairs or even canes. Simple things like that are all falling under both of these categories. So the next track is cellular engineering, which focuses on mechanobiology. Mechanobiology is the study of how physical forces affect cellular activity and understanding how physical stimuli in tissues and organs affect the body. So here we see a couple of different areas of research. So if you look at the top, our little animal friend has an ear growing inside of his body. That's a pretty new area in medicine, which allows us to preserve different extremities that have possibly fallen off or are needed to be regrown on our bodies to make sure that they're able to be reimplanted later on and still fully functioning. It also covers the regeneration or repair of tissues through the use of human cells, and some common areas of study are cardiovascular tissues, connective tissues, regenerative medicine, stem cells, tissue engineering, and wound healing. So, what's something that's really popular now is growing a heart out of tissues from someone's body initially, or from something like a spinach leaf. This is a really big area of research. So if that's something that you're interested in, you should definitely look into cellular engineering. Bioimaging is the acquisition, processing, and visualization of living systems using data analytics and statistics. So it's pretty much exactly what it sounds like. Some examples are X-rays, MRIs, CT and PET scans, and ultrasounds, and they reveal or diagnose and examine diseases. The medical imaging devices are used in clinical research, computer coding, etc. So this is a really good crossover between hardware and software. It's if that's something that you're looking for. Here's a quick video of someone beatboxing. So as you can see, it kind of shows all of the different muscles in the mouth and all of the different components that go into beatboxing. It's super cool to visually see what kind of goes on when you're generating sound. And so those are all types of things that you would learn within bioimaging. The last one is bioinformatics, and it's the analysis and interpretation of biological and genomic data. This is a really good area if you're really interested in coding or learning how to code. It combines computer science, informatics, and statistics. So, some popular areas are gene therapy, DNA sequencing, protein databases, and developing evolutionary trees. So, if anyone has ever taken the 23andMe test, all of the information that's gathered from there has been gathered by someone who works with bioinformatics. They compile data from different areas of the world to be able to trace back your ancestral origins, and that's super cool. Something that's relatively new is tracing for potentially dangerous genes in infants. So, if you are predisposed to having cancer and you don't want to pass that on to your children, that's something that can be marked in their DNA before they're even born or before even they're even conceived. So, that's something that's super cool. All of our coursework aligns really well with with the pre-medicine coursework. It can be fit into any of our 4 tracks within biomedical engineering if that's something that you're interested in. Even if you don't want to go into medicine, we do have really strong ties with the Carver College of Medicine and just the University of Iowa hospitals and clinics. A lot of our students will work at the hospital by doing some kind of research or internships or volunteering. It's a super great place. A lot of our senior design projects also work with faculty members from the Carver College of Medicine or doctors within the University of Iowa hospitals and clinics. We have a lot of opportunities for undergraduate research in the College of Engineering and the College of Medicine. A lot of our professors will have dual appointments within both. Um, the University of Iowa's strategic plan calls on the university to perform high impact research. So, as a senior, we do a capstone project called Senior Design, in which we work with a lot of industry professionals. If you look at the picture of the boy on the bike, that was one of our senior design projects. They were tasked to create a bike attachment for a boy that has an upper arm amputation so that he would be able to ride a bike, and it's super cool. If you just Google it on or if you just YouTube it, the video is super fun. It's like the cutest video ever. So those are the types of things that we do. We're also very conveniently located. We're only about 10-minute walk from the hospital across the river. So if you have to go do some research or maybe volunteer for a little while, you're able to just hop on a bus when it's colder or go for a nice walk. It's pretty nice walking over the river on the pedestrian bridge. So here are our amazing professors. We have professors in every track. In your 3rd semester, you get assigned one of these professors to be your faculty advisor, and they kind of walk you through what types of classes you should take to achieve your overall goal. If that whether that's going into industry or possibly seeking graduate opportunities. If you want to do research, all of our professors do research. We are a Research One university, and they're always really happy to take on undergraduate students. They're also very friendly and love just talking to students in general. So if you ever just want to talk about their research or anything at all, really, they're really happy to talk. So you just stop on by and let them know. So you might be thinking, okay, so I'm going to go to school for 4 years, study biomedical engineering, but what happens afterwards? Where can I work? What can I do? So apart from going to graduate school or professional school and you want to go into industry, these are some companies that will often hire biomedical engineers from the University of Iowa. We have anything from large companies like 3M, DuPont, the VA, or smaller companies like Athena GTX or Vita or IDX and things in between. So there's a lot of opportunities in pretty much anywhere if you want a small company experience or a super large company experience, there's a place for you. It was really nice talking to you all, and if you have any questions, please feel free to reach out. I'm more than happy to answer. I hope you enjoyed this presentation.